Hi, everyone. I'm guessing most of you guys are familiar with public transit systems. Today, we are going to dig into mass transit efficiency technologies. So, we're going to go over the sections that I need to get points. So, technology explanations, advantages, drawbacks, and barriers, and modern implementation. Before we dig into it, I'm just going to talk about some of the basics of mass transit. So, first, there's a difference between in city transit and between city transit. So, as the name implies, in city transit it alludes to transportation options to get around a specific city, which could include buses, metro lines, trains, ferries, etc. In this picture, I chose to include London's Underground because when I was about 19 or 20, it was the first time I had traveled outside of the US. And it was the first time I experienced a transportation system where I was just like, wow, I need that where I live. It was just mind blowing how easy it was to get from one part of London to another. And in city transit is going to be my focus for this presentation. I'm going to be mostly talking about efficiencies for buses, metro lines, and trains with for in city transit. Between city transit, I wish I could talk more about, um, but I just don't have time. It's transportation options from one city to another. It could include high speed rails, trains. I'm thinking right now, the biggest options are planes, which is the quickest way, but there's so many emissions, and trains, which are very slow. This map right here is just a proposal for a dream high speed rail. Maybe future generations will see, but how cool would it be if you could get to New York to California within a couple hours? All right, and why is mass transportation important? Because personal vehicle usage takes up so much space. It's crazy how 48 people can go from what we see on the right, with all of them driving their own personal vehicles. We probably need one or two more rows for it to be completely accurate, to 48 people in that bus. We are taking a lot of space up by having a culture that is focused on personal use vehicles to get us from point A to point B. So let's dig into efficiency technologies that can make our transportation systems better. Um, so, what makes efficient mass transit technologies? We're going to need things like accurate commuter data, efficient routes, and we're going to need to look at how we use energy and system infrastructure of the transit system. Efficient mass transit infrastructure must consider to optimize speed, routes, capacity, and energy. All right. So the next couple slides are going to explain the roles of each of those bullet points I just mentioned. All right, so accurate commuter data. Accurate commuter data can gathers information like where people are traveling to and from the most, with neighborhoods and businesses being in particular places. It's going There are going to need to be more stops from in certain areas compared to others. So, accurate commuter data can help consolidate routes to make it more useful to people. And then, accurate data can also feed into efficient routes to meet the needs of a city. So, I think that these two efficiency technologies, it's really simple and they go hand in hand. That data can be used to create efficient routes to meet the needs of a city. Efficient routes ensure that energy is not wasted going to parts of town that lack riders. So, why would we be sending a bus to a side of town where there's not a lot of people the same amount that we're sending it to the busy, high traffic business areas? It just doesn't make sense. So, making sure we have efficient routes can save energy and create a more useful transit system for people who live in the city and want to get from point A to point B. All right. And then obviously, when we're thinking about a transportation system, we need to think about how it uses energy. So, to achieve, we want to maximize our energy use. So, to achieve minimum energy consumption under the maximum train capacity, by controlling speed and acceleration. This is also commonly known as eco driving, which you can do in your own personal vehicle by not like accelerating super fast and braking, because at that point you're just wasting gas. So that could be easily implemented into bus driving. Whereas if it were to be implemented into a system or a metro system, it would need a control design to minimize energy consumption between stations. So it would restrict conditions such as average speed, acceleration, jerks, and braking. So all those things would be considered. All right. And while we're thinking about energy use, we're also going to be thinking about what type of energy is being used to power this mass transit system. So let's go into talk about system infrastructure. So if we're thinking about a city that has a metro system or a underground, we really want that to be connected to the electric grid so we can better control the type of energy being used, so we can control the emissions. Because if we can use renewable energy versus oil or gas, that is way better for the environment. And then also, there is for those types of mass transit systems, we can add in a technology design called regenerative braking, which takes the kinetic energy we're getting and turning it into electric energy during braking. So essentially, we are recycling the energy so we're using electrical energy to make the train move, and we're taking energy from the train moving and turning it into more electrical energy. So with that, we are saving energy, creating more energy. Um, this is seen in electric vehicles today, but it hasn't been implemented in a mass transit system quite yet. So, what are the advantages of implementing these efficiency technologies? One, the biggest one is we're saving energy and we're creating less pollution. And that's definitely what we need. Um, we are creating more accessibility for people within the city, and we're creating economic benefits for the city. So a lot of times, places with a really good transportation system become a popular travel destination because it's easy to get from one place to another. All right, and then drawbacks of this type of transportation system is it costs money to do these things. So um, it's not necessarily going to get approved. The high cost, people are going to argue whether or not it's worth it, especially when our culture is super focused on personal use vehicles. Why would we put all this money into a mass transit system and increasing its efficiency if everyone already has cars to get us from point A to point B? And then another drawback is it could create less accessibility while we are creating more efficient routes. Some people may be left out of that system. So those are all things to consider when creating a mass transit system. So let's look at modern implementation of these technologies. So data and routes. Efficient routes are a common technology in transit systems that we see, but they're not necessarily using intense data. I'm thinking there was a source that I referenced on the next slide. It talked about being able to use phones to see like where people are during what time of day and like where they travel to. Of course, people would hate if the government had that information, so it would never work like that. But just thinking about how that type of information could help contribute to a super efficient transit system. And then energy use. I already talked about how eco driving could easily be implemented into bus systems, but it's something that would need to be programmed into a metro system. And then system infrastructure. I talked about how regenerative braking is seen in electric and hybrid vehicles, but not yet in mass transit. And a lot of metros and undergrounds are currently hooked up to the electric grid. So that is something that might be easily, it's already a technology we see. It's just about how we can save the energy that we're using. All right, and then here is my reference page. Thank you so much for taking the time to listen to this presentation. I hope you guys have a great rest of your finals. Bye.